Dear students, welcome to the video problem solving with permutations and combinations. Permutations and combinations can be used to find probability of some certain events. Now let's see some examples. Example 1. There are 15 identical tins on a shelf. None of the tins are labeled, but it's known that 8 contain soup, 4 contain beans, label B, and 3 contain peas. If 7 tins are randomly selected without replacement, find the probability that exactly 5 of them contain soup. As given in the question, you are supposed to select 7 tins randomly. So the total number of tins are going to be selected is 7 out of there are overall 15 tins in a shelf. So the total number of outcomes will be combination of 15 and 17 because you are going to select 7 out of these 15. Now you are supposed to find, you know that in order to find probability of event A, it would be the number of favorable outcomes over the total number of elements of the sample space. So for the sample space, we will have 7, a combination of 7 out of 15 because there are overall 15 things and 7 of them are going to be selected, so it is possible number of ways for selecting. But it says you are supposed to find the probability of exactly 5 of the tins contain soup. So now you are going to have 5 actually tins containing soup. Out of how many overall, how many tins contain soup as given in the question? It is 8. So you are going to select 5 out of these 8 tins, but overall you were supposed to choose 7 tins, so 5 of them out of these 8 are going to be selected, so 2 more options there are to select. So the rest of 2 tins are supposed to be out of the tins which are not containing actually soup. So you have 4 plus 3, which is actually 7, because you know it shouldn't contain soup, so it should be selected out of the rest of the tins, which are beans and peas, which are 3 and 4, overall 7. So 5, what is the probability that 5 of them contain soup? So 5 is going to be selected out of 8, the total number of soups, and the rest 2, because 7 tins are going to be selected. So 2 more you need to choose, 2 out of the rest, which is 3 and 4, over the total number. You are going to select 7 tins out of 15 tins. So it will become 56 times 21 over 64 35, which simplifies to 392 over 2145, or it will be 0.183 as the final probability. Example number 2. A girl has a bag containing 13 red cherries R and 7 black cherries B. She takes 5 cherries from the bag at random. Find the probability that she takes more red cherries than black cherries. So the number of red cherries overall is 13, and black ones are 7. Now the question says that takes more red cherries than black cherries, and 5 cherries from the bag are going to be taken. So the number of cherries taken from the bag is to be 5, and the number of red cherries is going to be more than black cherries. So what are possibilities? You can select 3 red, 2 black, or 4 red, 1 black, or 5 red, 0 black. Now let's calculate. So it could be combination of 3 because these 3 is going to be selected out of 13 and 2 out of the rest 7 ones. Here will be 4 out of 13 combination. So then one black is going to be selected because 4 plus 1 will become 5. So the number of black is 7. And next possibility is to choose 5 out of 13, combination of 5 and 13, and no black cherries, which is 7. If you add all these together, it will give you 12,298. So these are possible ways to select 5 cherries so that the number of red cherries is more than the number of black cherries. Now, as it is a probability, so this is the number of favorable outcomes. So it will be 12,298 over. So what is the total possible number of ways? So you are going to select 5 cherries out of what is the total number of cherries in the bag. So it will be 13 red and 7, which is 20. So it will be 12,298 over 15,504, which will be 0.793 as the probability. Example number 3. A minibus has seats for the driver D and 7 passengers as shown. You see 1 seat for the driver and 7 passengers. When 7 passengers are seated in random order, find the probability that 2 particular passengers A and B are sitting on part A, the same side of the minibus, and part B, opposite side of the minibus. Now let's subdivide cases in the cases first. The two particular passengers sitting on this side. As you see in this side, there are 4 seats available, so they can have permutation among these 4 seats. It would be 4, which is the total number of seats available, and 2 of them are going to be occupied, so it would be 4p2. But if the 2 particular passengers are going to sit on this row, this side, as one seat is already occupied by driver, so there are just 3 possibilities, so it would be 3p2. Now for part A, as it says probability of the same side, so it will be probability of both on driver's side or both are sitting in the opposite to drivers. Both are on opposite side of the driver. Now, okay, probability that both are sitting on the driver's side. So the possibilities is 4p2 over, so the total number of possibilities, because 2 particular passengers may take any of these 7 seats, so the total possibilities will be 7p2 plus. Now here on driver's side, here it is driver's side. For driver's side it was 3p2 because there are just 3 seats available. Opposite side of driver, it would be 4p2 over the total number of ways, because there are just 7 seats available and 2 of them are going to be occupied. So it will be 6 out of 42 plus 12 out of 42, which is 3/7. Now for the second part, it says they are sitting on opposite side of the minibus. So we have the probability that they are sitting on the same side. So probability of opposite side, we know that they are complementary even. So 1 minus probability of the same side. The same side. So it will be 1 minus 3 over 7, which is 4 over 7.